Okay, so a little bit background about me. So I'm the chief. I have a few roles at Google. I'm the Chief Information Security Officer for Google Cloud Workspace, the AI businesses, and that includes all of what we do on risk compliance, privacy, security, all of the interesting topics that you all get to deal with. I'm sure probably quite a lot. I also cover the security engineering for the technical infrastructure that underpins all of the other Google services. And then for my sins, I also have a third job, which is being responsible for all of our field security and field CISO teams. And so what I'm going to talk about today is a number of topics woven together. So first is like how to think about delivering security at scale. And this is kind of based on my experience of having been a CISO and a chief risk officer for a long time, plus all of the experience and the work that we do with thousands of customers around the world. And then going deeper into how we think about the cloud, what we call the cloud security megatrends. So these kind of technology tectonic shifts that are driving how technology is being modernized, particularly in the cloud or in cloud-like on-premise environments. And then looking in more depth at how AI is transforming that, plus how to think about the risks of AI in a practical sense of how you integrate it into an overall enterprise. There's a lot of discussion about, which are all fascinating in-depth discussions about the intricacies of AI risk, but in reality, most of what people are doing is taking tooling, adapting tooling and deploying it into a large enterprise or a medium-sized enterprise or as part of their kind of end-to-end use cases. But first, I want to just kind of really set this up around thinking about how do you deliver security at scale. And I characterize this as shifting from the artisanal to the industrial. So many security programs today are full of individual practitioners that are highly expert, that do fantastic jobs, and we never want to lose those people. We want more of those people. But when you transition that ability to secure a system or a group of systems to how to do that at an actual enterprise scale in the medium-sized organization or a large organization or a global organization or a large public sector mission-oriented organization, it's a different set of skills that are required and a different set of capabilities to go from that small scale to that large scale. And when I talk about this transition from the artisanal to the industrial, so when you think about the individual artisans, those individual craftspeople in our security teams that do individual and bespoke work, their skills are hard to replicate, and it requires a constant attention. So you see many organizations have an effective security program, but it's characterized by the people come in every day and like spin some plates. And if they have a bad day or they take a day off or there's people that are not turning up for a while, after a while, those plates start to wobble and they come crashing to the ground. And then there's a security issue and everybody wonders, wow, they had such great people. What happened? And it was because they weren't scaling and industrializing. And when I think about industrialization, I want you to picture in your mind the high-tech manufacturing, semiconductor manufacturing, pharmaceuticals, high-tech manufacturing, as opposed to say 19th century steel mills, although some security programs look a lot like 19th century steel mills. But I want you to think about high-tech, and so this is shared tools and approaches, predictable outcomes, constant learning. Now, when you think about this is, what we don't want to do is we don't want to diminish the artisans that we have. We want to amplify the artisans. We don't want an environment where everybody's just a cog in the machine. So this industrialization is how you actually kind of scale these people. And there's 4 ways to do this in my experience. First is using metrics, and we'll talk about this in a second. The important thing is to have leading indicators, not lagging indicators. The second, which we'll talk at length about, is how to tap in to what you might call megatrends. So some of you may have heard of the phrase megatrends just in society in general. These are these unstoppable forces that are coming at us. It could be demographics, it could be energy sustainability, it could be geopolitical issues, it could be economics. The point being about these megatrends is you can't avoid them. You're either going to harness and amplify them for your own benefit, or you're going to get crushed by them if you don't position yourself. In technology, we're seeing a whole range of megatrends that are really driving towards cloud. Now, I know in the position that I have, I'm bound to talk up cloud. So, I will say in my defense that having spent many years in enterprises, building enterprise technology and using cloud, the fact that I kind of chose to come to a cloud provider is at least some testament. So I had this conversion before coming to the cloud that I think cloud is actually going to be one of the more transformational technologies to help shape security and resilience. Third, a big part of industrialization is how do we automate? And fourth, it's also adopting a number of industrial practices. So there's no magic here. You've got to do work to transition and scale a security program. So let's focus first on metrics. Now, the reason I get so obsessed about leading indicators as opposed to lagging indicators. So lagging indicators could be breaches, incidents, vulnerabilities, malware events, all of the kind of the negative things that you have to track. The reason I get so obsessed about that is when you look at, as I'm sure many of you have, look at high-tech manufacturing, they don't obsess on those lagging indicators. So clearly they track the quality of what comes off a production line, or the quality of a drug that's manufactured, or the quality of some semiconductor component that comes off the supply line. But what they actually focus most on is the leading indicators. So it's the quality of the materials that go into the process, the quality of the design for manufacturability, the quality of the machinery, the effectiveness of the culture on the designers and the production line that almost guarantees that what comes off the production line is of a high quality product. And we don't do enough of that from what I've seen in security. And so when you think about some of the characteristics of what these leading indicators could be, they have to be precisely measurable. And so like we all go like, well, of course, precisely measurable. But I think many people live in a world of high, medium, and lows and red, amber, and green. That's not a precise measurement. And again, I don't diminish the degree of work that is needed to get to precise measurement, but that has a benefit in itself. Measurements have got to be blameless. So in other words, you put the context afterwards. You don't put the blame in the measurement because otherwise people are going to game the measurement. Classic example of that, I've seen this in many organizations. You might have a department that is hitting 90% of their goals, let's say, resolving software vulnerabilities. And then you have another department that is only achieving 10% of their goals. And you might think 90% good, 10% bad. But if you build that into the metric, you could be making a mistake because in a particular organization, it might be that the team that's running the 90% level inherited that good position and is now about to crest down because they're really not paying attention to it. And the team with the 10% might have been taking a longer time to resolve things, but they've built some great framework and tooling that's going to propel them to 99.9, if not 100%, and keep them at it. So one team that looks good, maybe not good, and the team that looks bad may be actually fantastic. And so you've got to put the context around measurements. I'm not going to go through every one of these things, but the other one I would call out is they've got to have some adjacent benefits. So you can't just do the metrics and the leading indicators to drive security outcomes. It's useful if you can also connect them with some other commercial or some other mission benefit. And one example I always remember of this, something I did like many, many years ago in driving a much more reliable inventory and asset inventory program. You clearly need that from a security perspective. But one of the things it also benefits, it can have highly commercial benefits. So in this one particular organization I worked at, again, many, many years ago, a particular bank, we rolled out an inventory program and it was a lot of hard work. It cost a lot of money. It was going to be foundational to everything that we did. But the great thing as part of doing it, we found thousands of servers. And this was a large organization. We found thousands of servers just sat there in data centers, really kind of not doing that much, just consuming power and consuming space. And you're able then immediately to start deprecating those servers, redeploying them to other things, freeing up capital. And in the end, things like the inventory program and many other programs can pay for themselves. Incidentally, just, when as security people, we all occasionally commiserate with each other. I remember at that time sitting in a meeting of like bank security people where we all share horror stories with each other. And I remember sharing this story about the inventory and finding all of these servers that weren't doing anything. And one of my colleagues at another bank, I won't name them, happened to say, you know what? You've got it easy. We found a whole data center that was kind of like unused. It was full of servers. There was nothing running in it, and we didn't even know the data center existed. So again, the motto of that story is just when you think you're having a bad day, there's always somebody that's dealing with some crazier situation. Some examples of these metrics, and again, I'm not going to go through all of them, but you'll notice the examples, very few of them are actually purely security related. So the first one, software reproducibility. So this is a classic one where I think you as a group will all know that the more we can guarantee, reproduce, reliably reproduce, build and deploy our software at high frequency means that we can also have less fear of change, which means we can introduce security change, we can faster fix security issues, and we can generally get higher assurance over our entire software supply chain. So it's really, really important to track the percentage of what software you have that's reproducible. There's very few organizations that are, anywhere close to 100%. I think many organizations are probably down in the 10s and 20s, maybe 30s. There are obviously some smaller kind of digital native organizations that have built from scratch, particularly in the cloud, because as you'll all appreciate, especially given this audience, many of these things are more naturally achievable in cloud or cloud-like on-premise environments. And the reason I fixate on this one is it gives a common goal for organizations to achieve. And one of the classic examples I always use, because I actually think this should be a board metric, and everybody says, Phil, you're kind of crazy. That's kind of in the weeds detail. You're expecting boards to really comprehend a metric that says what percentage of software in your environment is reproducible. And my answer to that is yes. So imagine if the board, let's shift analogies to finance. So imagine if the board asked the chief financial officer, how have you got all of the books and records and ledgers and accounts under control? And the chief financial officer said, well, we kind of don't really have that. We have a few spreadsheets lying around, and this system, this thing over here, this business tracks accounts in one way, and this, group over here tracks it in a different way. And we can't really roll it all up together and really reliably know what financial position we're in. There'd be a new CFO in a heartbeat. Yet today, if you ask, and again, this is not a criticism of CIOs and CTOs because it's a very difficult problem, but if you ask them today, they're in that position that they're still struggling to bring all of the software under control, to bring it under a continuous integration and deployment pipeline, and to integrate security and control in the fabric of how software is produced. Now, again, the great thing, as we'll see in the next slide about cloud security megatrends, is that plus infrastructure reproducibility and some of these other leading indicators are absolutely what we can get to with cloud environments. The final one I'll talk about on here is systems stagnancy. So again, we talk a lot about legacy systems in a negative way. There's like I've even been guilty of this in describing, we've got to get rid of legacy systems, we've got to modernize. But you look at the word legacy and it can mean many different things. And in many organizations, the legacy systems are in fact the legacy, that they're delivering the most value, they're the core systems. And if they're well maintained, even if some of them may be a little bit dated, if they're well maintained, kept up to date, protected, they can be viable infrastructure and viable platforms for the company. But if they're not maintained, if they're stagnant, if they're running totally end-of-life software, they're not receiving updates, they're not capable of sitting within the broader control framework, then those are things that need to be eliminated. And again, I see a lot of organizations now distinguishing between the legacy and the stagnant as something to focus on. So let's dig into megatrends. So as I mentioned before, these are what you might describe as the unstoppable forces. And when a few years ago, when we sat down and looked at what's going on in the world of technology, and in particular, the world of cloud and service providers and other infrastructure, it started to become clear there were these kind of 8 megatrends coming at us. And again, I was observing these for quite a while, even before I worked at a cloud provider. But the first one is interesting. So economy of scale. So by definition, hyperscale cloud providers are hyperscale. But what that means in reality is that economy of scale that they have drives down the unit cost of control, such that more investments can be made in security, which benefits everybody universally that runs on that platform. So I'll give you one particular example. So a few years ago, we invested a lot of money in a technology that we call our Titan security chip. I think Amazon and Microsoft have something similar, but this is a hardware component we build into not just our servers, but a lot of our other devices as well. It provides a secure boot root of trust for validating firmware and the Android OS as part of building the secure stack on top of that. And it provides an ability for managing to reason about cryptographic keys at the core of the environment. So we invested a lot of money in building this. We actually now open source the design. It's called OpenTitan. But basically, we invested a lot in building this chip. Provides a great security capability. But when you amortize that over the scale of the fleet of servers that we have, it's minimal cost. It just adds almost no cost to the individual environment. And so we can enable these types of services, similarly with things like encryption, pervasive at rest, and in-transit encryption, and now also things like confidential compute that deliver encryption to the point of processing. You can do that at such a scale that the unit cost of that keeps going down. Now, the interesting thing about many of these megatrends is they work in reverse to shrinking on-premise environments, where because they're reducing in scale, the unit cost increases. And so again, tapping into a hyperscale cloud provider or another type of service provider that has scale enables you to get a reduced unit cost of control, which ultimately benefits everybody. The second one on there is shared fate. Now, this is a tricky one. So everybody knows about the shared responsibility model, which is contractually and legally correct. But I don't think it's like spiritually correct in the sense that cloud providers occasionally hide behind that line of shared responsibility. And if a customer has a misconfiguration, the first thing a cloud provider might do is go, hey, like it wasn't us, that was like a customer configuration issue. We're trying to change that by moving across that line of shared responsibility into something we call shared fate, and thinking, if a customer has an issue, what can we introspect and look and say, what was it about our secure defaults? What was it about our configuration? What was it about the tooling or the training or the other capabilities that made it difficult for customers to run securely in that environment, and introspect on every type of event? And this also colors other different types of philosophy. So, for example, we have an insurance product that we set up in partnership with Munich Re and Allianz, where running on our cloud platform, you can get discounted cybersecurity insurance based on your ability to export the configuration to the insurers so that you can inform their underwriting process. And we provide the environment and the backstop for a lot of that to work. So that's another expression of shared fate. And then on the subject of AI, some of you may have seen this in the past few days. We announced that we will indemnify all customers from any intellectual property dispute in the use of our foundation models. So again, across the industry, there's a lot of questions around, if you're going to take one of these foundation models that's been trained on a whole collection of data, some of which in some models, not ours, may be based on proprietary data, and then you use that model to generate your own content, are you at risk of being sued by the original copyright holder on some of the training data? We spent a lot of time making sure that we have solid provenance of our foundation models, which is why we can make a statement, again, the expression of shared fate, that we will underwrite and take the IP risk as part of guaranteeing the IP integrity of customers building on our foundation models. The third one is healthy competition. So where all the cloud providers, and in fact, many other service providers, we're now at competition every single day on security. So whenever we get an RFI or an RFP, security is not down there at number 8. Security is there at 1 or 2 as one of the selection criteria. And between Amazon, Microsoft, and Google, and some of the others, we compete very heavily, not just on security features, but security quality. Everybody likes to think they do better than the other, but I think there's kind of unevenness in everybody's comparability. But there's a lot of competition. And now that, for me, that's the first time, at least in my career, that's mostly enterprise IT, where there's been pretty cutthroat competition to improve security. I think most of you that have worked in a classic on-premise environment will know the routine where you sit down with large tech company or large software vendor and say, I really would like extra security here, here, and here. And they go, whoa, you're the first people that have ever asked us for that. We're going to have to construct some special kind of cost framework for that. And then you go speak to all your friends in the security community and they go, yeah, we asked them for that. And they told us the same thing. The great thing about cloud is everybody gets to see what the security is. In some cases, very good. In some cases, not so good. But there's a lot of transparency around that, which is driving the market to improve. Very, very different than, in my experience, from enterprise, classic on-premise enterprise IT hardware and software. Fourth on there, cloud as a digital immune system. So this is the one that I'm, probably most excited about, and it's relevant to what we'll talk about in a few slides on AI, which is because we're applying so many updates all the time. So we put out hundreds of updates a month. It could be adding a new security feature. It could be changing a default control to make things easier for customers. It could be resolving a vulnerability that we found through our own threat and vulnerability research. It could be responding to a threat we've seen somewhere else in the world that we're upgrading the environment, or it could be a vulnerability fix, or it could be something as a result of a bug bounty discovery where we're fixing something. But the bottom line is we're pushing out hundreds of updates every month. And this is like a constant, rising tide lifts all boats approach, in that if you're a customer and you don't necessarily have a large security team, or even if you do, you just sit back and take these updates and you're just continuously getting better because the way we're wiring everything together. We've definitely found this since our acquisition of Mandiant just over a year ago, where we're able to pool Google threat intelligence with Mandiant threat intelligence and really look at where we need to apply updates. And in some cases, we've been able to get tactical updates out on the platform to mitigate issues before the actual vendor of the software that had an issue had updated it themselves. We've been able to put some shields around that deployment. And again, thinking about this, it's acting like a digital immune system. And again, I'll talk in a few slides about how AI is actually transforming and powering that even more. When you come to the software-defined infrastructure, so again, you all know this, being the audience that you are focused on cloud. The great thing about cloud or cloud-like on-premise environments is it's a software-defined infrastructure, so you can declaratively specify what you want the environment to look like. You can analyze that configuration. You can confirm that the deployed configuration matches expectations on a continuous basis, because as we all know, most incidents don't necessarily come from awesome attack capabilities. They come from exploiting vulnerabilities that have been left in misconfiguration or some other kind of absence of thought and absence of monitoring. And cloud really kind of helps that. Similarly, cloud promotes this software deployment velocity, because we can't help but provide tools that force people into increased software deployment velocity, because that's how we run the environment. And so all of the tools that we provide to run on it naturally promote an increased integration between the software developers, the security teams, to drive increased deployment velocity. Now, the seventh one, as I kind of come to the close on this slide, is the one that where people normally start throwing rocks at me. So the megatrend of cloud is simpler than on-premise IT environments. Now, anybody that's ever sat down at any of the cloud consoles has not really thought, wow, this is such a simple and intuitive environment. But actually, when you think about it, so let's see where I'm going with this. Again, anybody that's had experience of on-premise IT knows that you don't really get, very few roles are exposed to the full complexity of IT. So in any kind of medium to large organization, you've got a loose flying collection of people's jobs. There could be storage engineers, database administrators, software engineers, security engineers, network admins, network engineers, some cases software architects, middleware engineers, a whole array of people that deal with this distributed complexity. And therefore, very few individuals are actually seeing that complexity in total. And so there's no incentive in the system to actually simplify things. So when you switch to a cloud environment, everybody's exposed to the full complexity. And a few years ago, that was actually quite painful. I remember dealing with this with myself. But because everybody's seeing it, we get this massive push, as do all of the other cloud providers, to provide abstractions, to simplify it, to make default configurations easier, to come with default configurations for complex environments, that abstract that away. So because everything's put in front of people, cloud becomes this kind of abstraction generating machine because of people's demand to do it. A classic example of that, so Kubernetes. Again, Kubernetes not renowned as the most easily and simple thing to manage, but if anybody's ever managed a distributed transaction broker and a database and messaging environment across 5 different vendors using various different publish subscribe systems, cluster management systems, job scheduling systems, you then come to Kubernetes and you go, wow, this is really nice and integrated and simple. But the great thing about the perception of Kubernetes being complex is what it's done. I can only speak to us. I'm not that familiar with what Microsoft and Amazon do, but it's driven us to put more and more abstraction layers. So we have Kubernetes, We have our kind of Kubernetes enterprise layer, what used to be called Anthos. Then we have managed Kubernetes, which we call autopilot. And so you can, and then you all the way get up to kind of serverless environments where the security and the configuration and the manageability is built in because it's been driven through that abstraction, generating requirement coming from presenting customers with the full range of things. And then finally, I won't spend a lot of time on is sovereignty. So there's a lot of issues around the world where companies are being compelled to have localized data. And again, cloud definitely helps that because we have data centers everywhere. So you don't have to build your own data centers everywhere. So while we think there's other options to data localization, we absolutely support sovereignty in every market that we operate in. And that's something that people find valuable. So now let's talk about AI. So, when we came up with these 8 megatrends, we didn't include AI. And in hindsight, that was kind of a mistake, but it was rational in the sense that, and the reason we call it kind of the sleeper megatrend, is AI has been just so pervasive. So I think a lot of what people have been doing. So any of you that are Gmail users, you get protected by AI every day, malware filtering, spam filtering. If you're using the Chrome browser, an AI system, augments and defines the safe browsing list that defends many people across our cloud products. You've got tools. Exciting tools in the threat management, security operations, but even more equally important, but kind of mundane tools like our IAM recommender that is a machine learning based tool that analyzes discrepancies and anomalies in how privileges are assigned. So AI has been ever present, but as we all know, in the past 12 months, we've seen the rise of generative AI tooling, which again is further transformational. And we've been using it a lot internally. In 2018, as many of you probably know, we invented the transformer technology that this latest generation of LLMs is based on. Now, when we think, I'm going to talk about 2 slides now. First, how to think about the risks of AI. And we actually published a framework we call the Google Secure AI Framework. So if you Google that, you'll find that pretty easily. And there's a whole set of documents around how to think about building an AI risk program. Again, there's a lot of technical detail about AI specific risks, but I think for most organizations, the real concern is how do you build a security framework to manage AI and to securely and safely deploy it inside your business, your IT, your business processes, or your mission processes. And really the way I kind of characterize this is to think about AI risk in three pillars. So first, it's software like everything else. So you've got to have a really great software security program around your AI software. You've got to manage the software. You've got to have a secure software supply chain. You've got to understand where the tooling comes from. You've got to understand how the software is deployed, how the models are deployed within the software. And so it's a software security problem. The second is it's a data governance problem. And so you've got to manage the provenance and integrity of the training data. You got to manage the security of the model weights, the adapter weights, and various other parameters that drive the model. But the other most important, what I perhaps think is the most important thing, because it's often neglected, is the security, provenance, and governance of the test data. So we see a lot of organizations, they get really good at managing the training data, they lock it down, they have great provenance, they get really good at securing the model weights and the model itself to protect that from any types of internal or external poisoning attacks. But then they don't protect the test data. And as I'm sure many of you know, if you can mess around with the test data because you're continuously testing the model and the model learns depending on whether the test is good or bad, you're corrupting the test data can corrupt the model. So you've got to think about this as an end-to-end data governance problem. And while there's many organizations that are good at software security, there's not a lot of organizations that have it in their DNA to be good at data governance. So you as security teams, I think, have to think now, how do I partner with my chief data officer or the data organization or various other roles to create a really foundational data governance program? And the third pillar is what you might call operational risk or operational security, which is to say these models, you end up deploying them inside a business process. And that business process could be interacting with people, in which case you've got to have input and output guards. And typically those will be LLMs in themselves that are trained to independently check and protect the model from rogue input and to defend the output to make sure you're conforming to whatever your trust, safety, and security goals are. But also, if you're thinking about deploying a model inside a business process that could affect transactions, business data, could actuate physical processes, you're going to need to build some circuit breakers around that. You're going to need to build some guards around that. And again, very few organizations outside of maybe the safety critical or financial trading industries understand how to build guards around systems because they're used to systems being predictable in how they deploy them. And again, so we think about this, it's a software problem, it's a data problem, and it's an operational security problem. The underlying thing of all of this that we've found most useful as well is to create a red teaming program for AI. So we now have a dedicated AI red team, which has been very, very useful. So no matter how great our security vulnerability people are, our trust and safety people, our compliance people, everybody else, they do a fantastic job. But as soon as you take a model and stick it in front of a bunch of people that have, I think I've lost the, do you want me to do it? Are we having a problem with this? All right, no worries. I'll wait for the mic. I'm going to take it. All right, so the adversarial red team is important because as soon as you sit down somebody with an adversarial mindset, an LLM prompt, their brain is going to take that model to a different place. And so it's really, really important to adversarially red team. We've actually put together an AI red team guide, which again, if you Google AI red team guide, you'll be able to see how we built that, the types of things that those teams do and how we're evolving that. Now, moving on to kind of how to think about using AI for security. So we typically think about this in three ways. One is it's how you think about threats and how you manage threats. Second is how you reduce toil for your teams, and then also how you scale the talent you've got. So first on threats. So we've trained one of our large language models called Palm 2 with a lot of our Google and Mandiant and some other threat intelligence and security configuration data, and created a thing we call SecPalm 2. And what this does is this drives increasingly some of our security operational capabilities in the products, and also enables us to decode malware updates into VirusTotal. Some of you probably know VirusTotal is a Google company, and so we feed that into our SecPalm 2 model, which drives the generation of rules and configuration, and then we use that to kind of create this faster feedback loop between a detected threat and a mitigation that occurs. The second thing is, and I think this is really impactful for everybody, is the reduction of toil and effort that teams have to make. So we've created a whole set of technologies, having been trained on our secure coding practices and many secure code examples and secure cloud configuration and good examples of, and vast arrays of good examples of recommended cloud configs. We have a whole series of technology that we label Duet. And what this does is it lets people kind of specify what they want, and it will generate a configuration, and that configuration will be based on kind of secure configuration guidance. And then similarly, we're increasingly driving out technology to assist software developers in not just producing better code, but producing the boilerplate that surrounds their code that can enable them to generate more secure environments. And then the third and final thing is we think all of this enables us to scale talent. One of the things I've certainly spoken a lot about is when you think about the challenge of the cybersecurity workforce, you've got to look at it on both sides of the balance sheet. We can't just focus on trying to create more cybersecurity professionals, even though that's really important. We've got to think about how do we 10x the productivity of the cybersecurity professionals we've got. And for me, the big promise of AI is that's going to enable us to scale the talent we've got, and not just scale in terms of numbers, but scale the skills. So we're finding that many of these AI tools can actually help us take, a junior engineer or a junior analyst up to a higher level of performance, and a mid-level analyst and engineer up to a near expert level of performance. And it amplifies even more the capability of the experts because they're augmented with this tooling. So again, looking at AI now, not forgetting the massive amount of existing deep learning based capability that exists, but now how to amplify and use these LLMs for higher speed threat management through to reducing the toil of our teams and amplifying the talent that we've got in the industry is going to, I think, be incredible. I'm going to start wrapping up now. So the third big pillar of scaling a security program is automation. So again, I touched on at the beginning, one of the reasons I get so focused on continuous control monitoring is when you look at many breaches out there, they're not necessarily some awesome attack that imagined some new path through a system. They're most often than not some control that should have been working that wasn't. And you can imagine sitting there in the post-mortem room and everybody's talking about the attack or the incident or maybe the close call, and somebody's hand goes up at the back of the room and somebody says, hang on a minute, didn't we have a control that's supposed to stop that? And then somebody says, yeah, we did, but it got switched off 2 weeks ago as part of a deployment, or it was causing too many performance issues and somebody switched it off and they didn't re-enable it and it didn't go through change control. So it's always some kind of issue like that, which is why it's so important to do continuous control monitoring, which is to understand your control catalog, monitor it for effectiveness, consume data from that environment to make sure that the controls are working as expected, and then just do that in real time continuously. Again, this is not necessarily easy. It's easier for some types of controls than others. But here's the most important thing, and this is probably the most painful thing, is when you find a control that is otherwise quite a good control, but it's incapable of emitting the data that would then enable you to continuously monitor that control is effective, then you've got to declare that a bad control and replace it. And everybody's going to hate that because it's otherwise a great control and it's working just fine. You just can't monitor it and therefore it's a bad control. Now, the fourth and final thing, when you think about industrial practices, so again, back to the manufacturing analogy, is when you've got an industrial plant or whether when an organization is improving their industrial design, they actually do some things. They don't just say, I would like, to move from the artisanal to the industrial. They actually go do a set of activities. And again, I'm not going to go through this in a huge amount of detail, but just to kind of illustrate some of the transformation we've done over many years that we work with many organizations to do, is the first one on technology. When you think about security integrated with technology, we've come from a world where you get technology and then you get some security products and you jam it into the technology, you bolt it on after the fact. And we're now at a world where we have to get quicker, and I'm sure all of you are driving towards this, that the security is default on and then ultimately fundamentally engineered in. So we spend a lot of time across our products. We have a great security products team, but I probably spend more of my time with all the other products, making sure security is built in by default as much as we can in all of the other products. Similarly with operations, we've moved from a world of manual to automated, but in many respects, when you look at a lot of security programs, what they've done is they've automated the manual as opposed to rethinking what their operations should be to get to a more what you might call an autonomic environment, where the environment is increasingly self-defending. And again, this is where AI can actually fuel that. In many cases now, what we're doing with some of the SecPalm 2 stuff is helping a lot of customers just get totally hands-off and even ditch some of the more traditional SOAR type approaches, where you're not just surfacing up a detection with an automation that a previous human operator may have done. You're actually putting things down at a lower level so things are more self-defending. In terms of talent, we talked about that, is how do we get from specialized to more federated and localized, and ultimately to equip all of the people in an organization with the technology. Similarly, the AI promise is there for that. I can't think of a role now in any part of technology or in any kind of business engagement on technology where somebody soon, either now or in the future, isn't going to get some AI assist in how they're building, configuring things, and doing that not just in a way that amplifies their productivity, but helps them secure things from the get-go. Risk, we talked about transitions from shared responsibility to shared risk to shared fate. And then finally, and back on the threat intelligence piece, something we're spending a lot of time in various public-private constructs is how do we, again, using the AI technology, but all of our other electronic pipes that connect threat sharing with organizations, get from a relationship-driven approach to sharing between people through to not just the electronic sharing, but a set of enduring pipes that will permanently connect our environments to drive this much broader digital immune system for the environment. And we're seeing already great effect of that happening in various parts of the industry today. So let me just wrap up. So I would say industrialization takes a deliberate effort. It's something where you've got to shift from manual individual into automated and enterprise is a deliberate activity. we think tapping into these cloud and overall IT megatrends helps fuel that. And certainly if you, I would advise against positioning yourself against it, not to kind of debate it, but when you position yourself against a megatrend, you're usually going to have a tough time. And then ultimately, when we're driving towards what we think about the future of security, ultimately speed is our best defense. There's many technologies where we can wire threat information together, control attestations. I didn't really talk much about OSCAL today, but this is, again, open standards control automation language, I think is going to have a high degree of automation opportunity for sharing information across enterprises about continuous control monitoring. But ultimately, for cloud security, for how we scale organizations, and how we think about the adoption and application of AI, ultimately it's about speed, because speed's our best defense. And if we can outpace the attackers, then we're going to be in good shape. So I'm optimistic for the future that all of this drives towards speed. So I'm showing 5 minutes left. I think somebody's going to tell me if there's any questions in the room or any questions on Slack.